Hello everyone. Good morning, good afternoon, good evening. My name is Marcelo Zambrana. I hope you're enjoying HashiTalks and all the amazing presentations. A little bit about myself. I am a software engineer at Microsoft. I love open source and data and AI, but I also focus on automation, and I am a big fan of DevOps in general. So today I'll be talking about how we can automate the creation of golden images, and how we can deploy them to multiple cloud providers using tools like Packer, GitHub Actions, and HCP, HashiCorp's cloud platform. So let's get started. As you know, multi-cloud has become popular in the last years, especially as organizations and enterprises keep migrating to the cloud, and at the same time they seek to diversify their infrastructure and reduce dependencies on these cloud providers. One big challenge they face is golden images. Those application and security customized VM images that are used as templates to create more VMs. One big challenge is the lack of standardization in the way these providers create, manage, and deploy these images. Each cloud provider has its unique way to create, storage, share, and even manage them. To make this even more challenging, integrating all these cloud providers is complex by nature, and it requires significant technical expertise and investment, especially at the beginning. So I think organizations are forced to develop custom solutions in order to overcome all these challenges. So what I have here, it is one solution, one way to solve this challenge. The general idea is to have everything centralized and automated, of course, where developers only push code, and that triggers a set of actions that builds these golden images and push them to each provider, and stores the metadata about them in a centralized place, in this case HCP Packer. So it's easy to use them and integrate them with other DevOps tools like Terraform or configuration management tools like Ansible. But let's start with the demo, and let me show you some code on how all this works. Okay, so demo time. What I have here, it is GitHub, because I think it's the heart of this solution. And again, all this code is going to be open source in my account. But as you can see here in Actions, I already have one trigger. And as you can see, the build, it has all the steps to deploy this solution. It goes to logging into each cloud provider, does the set of Packer init, Packer validate, and Packer build commands. And as you can see here, it goes through one by one, creating these and going through the whole process. But before going into the code, let's try to trigger one. This build could be triggered manually, or could be triggered by a new commit. So let's do one commit. Let's call it new version. I forgot to add the changes. And let's push these changes. Okay, so this will trigger a new build, as you can see here, new version. And it will go through all the same steps. It will set up the job and everything. But while this is running, let's go see some code. So here we have VS Code, and we're going to focus on these three files: build, Packer, variables, and main.yaml. So here, the main file, build.packer, we have everything that this Packer file is going to do. As you can see here, we are pinning some versions and plugins that we're going to use. And here we are defining which VM image we're going to use from each cloud provider, one by one. The next step is to do the build based on those sources. And the last step is to push all that metadata to HCP Packer registry that I have. In the variables file is where I try to customize and have everything as a variable. So it will be easy to customize or extend if it's needed. the default username that's going to be using it to SSH into each VM. And here what I'm trying to do is to make it this configuration generic using HTTL data structures. As you can see here, each block, each map has the configuration for each cloud provider. So in the future, if it's needed, we can add one more set of configurations to this variable, and Packer will just use it, right? Or if we want, we can customize which version the image we're going to use, VM size, things like that. So here is a good section where you can see how all these image factories work and how are different from each other. As you can see, some of them require different type of variables and arguments in order to make it work, right? And at the end, I want to standardize all of them using the same tags. It doesn't matter where they are going, I want to use the same tags so it's consistent across all of them. And here are some specific authentication variables I'm using in order to authenticate into in this case, Azure. And in this case, GCP. Going to the automation part, this is also a little bit familiar. I'm using secrets in order to authenticate all of them. But one thing I want to see is, for once, I'm using a self-hosted runner. If you haven't used self-hosted runners in Azure, in GitHub, you are missing, because it's so easy and it's really fast. Just 3 commands and you have your self-hosted runner. Easy to use. What I'm trying to do is to use the native GitHub action authentication method, so it's easy and familiar, right? I'm using one for each one of them, and I'm just passing those secrets to authenticate. And at the end, this is just the standard Packer commands. I'm using Packer init, which initializes the environment and gets the plugins. I use Packer validate for validation purposes, just some minimal validation. And at the end, I'm using Packer build in order to build all these images together in parallel. So if we go back to GitHub Actions, as you can see, all of these have been triggered. Packer init has been done. Packer validate has run, and it says that the configuration is valid. And if you see here, Packer build has started, and it's starting in parallel. So it's sending all 3 jobs to all providers, and right now it's building all of them. And as you can see here, it's first creating a VM with the configurations we gave them. And once the VM is ready, it SSH into it and starts doing all these configurations. And once the VM is ready, it takes an image out of it and pushes it to our registry. As you can see here, logging into each one of the cloud providers, and now it's building these images. And if we go to each one of them, as you can see here, a new image is listed here. If we go to Amazon, probably the second AMI is there. If we go to GCP and we refresh this, we can see that the image is there. And one thing I want to show you is the standardization I was showing, the tags I applied to all of them. Here in GCP are labels, like environment, owner, project, team, all that stuff. And pretty much we can see the same here in the AMI. We can see probably it hasn't finished yet. But if we go to Azure, Amazon is a little bit slow. You can see the tags is already there. The tags are already there. Let's give it one more try. It says it's available already. So the tags are there. So yeah, that's awesome. So probably that means that Packer is about to finish. And the last step, as I was mentioning here, as you can see, this is my Packer registry. As you can see here, this is my packet. Version 1 was deployed. And as you can see, the platforms that is supporting, all 3 major cloud providers. Probably if we refresh and give it a couple of minutes, probably we're going to start seeing the latest version. Right? If we refresh this is version 2 now. So if we go to inside, you can see version 2 is active, the platforms that is supported, and the labels I use. Here I have really useful information if I want to integrate this with Terraform, for example. I can just select which provider I want to use, which region I want to use, and it will generate the code for you, right? Everything centralized in just one place, which is awesome. right? As you can see, everything finished. I have my metadata here in Packer, and yeah, all the information is here. And here are the versions. As you can see, this is the previous version we had, and this is the latest version we just deployed today. So yeah, this is awesome. Luckily everything worked. So, but yeah, all the code again is going to be available in my GitHub repo. It's going to be open source, and as you can, and again, I try to make it as simple as possible, but at the same time show how HCP Packer is really powerful in order to have a centralized place where we can store all this information. Okay, so going back to slides. Let me go back to slides. Some key things I would like to mention are plugins. Plugins are awesome in Packer. Plugins configuration, those who are familiar with Terraform providers will see this familiar. And the same way Packer has plugins for multiple providers, which is great. And as you can see, you can pin the version you want to use and the source where it's going to get them. So I like it. It is easy to use, and you just do Packer init and we'll get everything for you. Next, the integration with HCP Packer is so easy. As you can see, this line of codes, and this integration is really powerful because it allows us to store all the information about these VMs metadata in just one central place. And as you can see, you can version, you can customize it, you can put labels, and even you get snippets of code how you can integrate with Terraform, for example. Next, cloud configuration. So here I try to take advantage of HCL data structure, as you saw, to have a generic and easy way to customize this plugins provider's configuration. So we only make updates in one place, or if we need, it will be easy to add more, right? You just add another set of code to it, and you add the source and the plugin, and in theory it should work. So yeah, HCL variables and data structures are really powerful in order to customize these variables, right? So moving on to GitHub Actions, I try to leverage each cloud provider native authentication as you saw in the demo. One really good improvement here will be to use OpenID Connect or IDC in order to make the authentication. It will be cleaner and more elegant, but I just want to use these just to get started, and it is something familiar that everyone knows, right? But again, this could be really improved, but I think using GitHub Secrets is one way of using it. And well, to finalize some key takeaways and steps. At the end, this solution tries to close the gap across all these image factories, as I call them. Have a centralized place for all these golden images metadata, and at the same time tries to increase agility so these organizations and enterprises can take advantage of new services and features offered by these cloud providers. At the same time, it will be easy to scale resources across all of them, right? Allowing for more efficient use of resources, and of course increasing flexibility. And these are just some of the many benefits of having this kind of automation in place. For developers, having everything as code, it's amazing, right? We have version control, it's always a plus. So we can also apply software development practices, submit PRs for code reviews, roll back if something goes wrong. So lots of good things when you have everything as code. And well, this is just getting started. To be honest, this session is just part one of two, or probably many. The next step will be integrating this pipeline with other DevOps tools, like I was saying, like Terraform, and configuration management tools like Chef or Ansible. And this is to create more complex configurations, do hardening or even testing if it's required. We could also use more GitHub Actions functionality, like approvals, environments, and a lot more. Again, we just scratched the surface with this solution. And we also scratched the HCP Packer functionality. And there are more things that we can take advantage of, like channels that we didn't see. But we saw iterations, which is how you manage versions inside HCP Packer. For example, what happens when an image is deprecated and needs to be removed or revoked, right? Or the opposite, when a new updated version comes along. So stay tuned for the next parts. Maybe I'll see you at HashiCorp Global later this year, hopefully. It will be an awesome opportunity. But with that, I just want to say thank you for tuning in. I hope you enjoyed this presentation and the demo. Luckily, it worked. All the code I showed today is going to be available in my GitHub account. It's going to be open source. Please free to contact me if you have any questions, comments, or you just want to say hello. And finally, thanks to HashiCorp and the whole team for this amazing opportunity. I always enjoy trying to share some knowledge in these sessions. But thanks everyone, and until the next time. Bye.